The Sun has unleashed an enormous X-class solar flare, temporarily triggering a radio blackout above parts of the US and unleashing a hefty coronal mass ejection that will likely slam into our planet, potentially triggering vibrant aurora displays later this week. Sunspot AR3842 erupted with a Class X 7.1 solar storm on October 1, 2024. NASA models predict that a coronal mass ejection caused by the storm will head towards Earth. Class X indicates the most intense storms, and the numbers provide further information about their strength. The Sun appears orange and red with dark spots and bright yellow areas against a black background. The lower left area of the Sun's surface has a bright yellow area called a solar flare. NASA confirmed that this massive eruption caused a massive ejection of solar plasma and high-energy particles, a coronal mass ejection that is currently heading towards Earth at hundreds of miles per second and will impact the atmosphere on Friday, October 4th. This eruption was 7.1 times larger, making it the second most powerful solar explosion in solar cycle 25, the current solar cycle that began in 2019. The most powerful eruption was a gigantic 8.7 times larger explosion that occurred in May, which was the most powerful eruption in the past 7 years. If a coronal mass ejection strikes Earth, it could cause magnetospheric disturbances, so-called geomagnetic storms, that could send solar particles deep into the atmosphere and cause vivid auroras at unusually low latitudes. A similar geomagnetic storm occurred in mid-August after another X-class eruption hurled a coronal mass ejection directly at us. This increase in activity is evidence that the Sun has reached solar maximum, the stage in its 11-year cycle when solar activity peaks. That means we're likely to see even more destructive alien forces descend on Earth before the end of the line. Scientists initially predicted that the solar maximum would begin next year and would be less active than previous solar cycle peaks. But it soon became clear that the Sun's explosive peak was occurring sooner than expected and was more active, forcing researchers to update their predictions for the first time in the Sun's history.